Tonight is May the 2nd, 2014, and I'm going to do a video on transformers. I know that there are a number of videos out there, and most of them are theory. This one is going to be the least amount of theory possible, and the only theory we're going to get into, the only math we're going to get into, is once we know the turns ratio, we'll know the impedance ratio, and that'll be toward the end. Well, first of all, there are a lot of things that look like transformers, like this guy right here. This is not a transformer. It's a choke. See, it has two wires, and it's a pretty big choke. It's even got it stamped on there. Some things we're lucky and we can just read right off and see what it is. It's 25 millihenries at 8 amps, I believe. There's a choke. Here's a much smaller choke. Probably came out of some little audio amplifier once upon a time. Another one, another choke. Choke, two wires. This goes in the power supply. One end of the choke goes to the output of the rectifier. The other end goes to the filter capacitor. There's actually usually a filter capacitor from this side to ground and from this side to ground. It's called choke input filter. Okay, those are chokes. They look like transformers, but they're not because they only have two wires. Now, we've got a lot of transformers. I've got more transformers than the law allows. This is rated at 50 watts. Good sized transformer. I've had it many, many years. It's a hi-fi type 50 watt amplifier with 4, 8, and 16 ohm outputs. I have rewired it over the years because I've used it many different times in different amplifiers. Never seem to keep any of them. I always keep them for a while, then take them apart and build something else. This is the primary. This goes to the plate and the center tap. And we got 4, 8, and 16 here. We're going to determine how to get this 4, 8, and 16. But I've got to show you a bunch of transformers so that you'll understand. Okay, this is a transformer. See, in the old days, and you're going to run across a lot of old transformers, because most of them are still good. The old way of doing it, there is a transformer code, and the code is generally the primary is black wires and the secondary is some other color. Yellow was typically 5 volts for a 5 volt winding like a 5U4. This happens to be a 2.5 volt 10 amp transformer. It's for like 866s, mercury vapor rectifiers, or 3B28s. You can see the secondary winding right here. If you can see the size of that wire right there is rated at 10 amps. That's the output side. The primary would be a lot of turns of very small wire, probably number 28. This is probably, I'm going to guess, at number 16 or maybe number 18. So you can, if you don't know what the transformer is, if it doesn't have all of the labeling on it, pick it up and look at it. Feel how much it weighs. That'll tell you something about how much power it'll handle. Look at the color coding. That might be the truth. It might not. It's deceptive sometimes. Like I say, yellow used to be for a 5 volt. In this case, it's 2.5. Okay, here's a big 6 volt filament transformer. Is it 6? Yes. See, this is a 6 volt 20 amp. This is obviously the secondary, obviously the primary. 120 in here, 6 out here with a center tap. The center tap usually is a striped wire. See, we got 2 greens and a stripe. So this is just a 6 volt 20 amp filament transformer. I'd light up a bunch of 6L6s for you, wouldn't it? Okay, yeah, here's another transformer. This is a high voltage power transformer. I just happen to know that this thing is rated at 2400 volts no load, 2000 volts under full load. Now, this is an old style transformer, and it's heavy too, and it has black. You can pretty well look at this thing from experience and say, this is the primary. See these little tiny wires right here? This is the secondary. We've got a red and a red yellow. So this is the high voltage and this is the center tap. You got to be careful with these things. These kind of transformers, when they're not plugged in, they're no more dangerous than a rock. if you drop it on your foot. Here, what is this? This is going to be the 5-volt filament winding. Now, if you plug this thing in and you start tinkering with this, you can get killed. No doubt about it. So we're going to go over some of that stuff. Now, they always tell you, make sure that when you're working with high voltage, you always have somebody with you and they know CPR. Well, good luck. I don't know CPR. So there you go. And you want somebody with you in case you get shocked. There's a yin and a yang to that, and I'm here to tell you because I've done this all my life. When you've got people around you, and you should not be working on high voltage. That's my opinion. Because when people are around, they're yappity, 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 yap, and telling you this and asking you that, and you're trying to answer them and you're not paying attention. When I work in my safest environment out here in this workshop, I do not have my cell phone with me. I do not have a telephone with me. I do not have anything that can scare the wits out of me. Because when I get concentrated on working on a 2,000 volt transformer or a 2,000 volt power supply, or if you watched any of my other videos with that the kilowatt 3-400Z amp at 3,000 volts and actually sorting up to 4, this is just deadly. You're playing with a pack of rattlesnakes. So I work on them alone because I choose to. Because I'm more likely to be alive at the end of working on them because nobody has distracted me. That's just the way I look at it. You can look at it any way you want to. You don't have to take my advice, that's for sure. Okay. Some small output transformers. That's what this whole video is going to be about. I'm going to make it in 2 parts so it won't be so horribly long. This is a little output transformer. It's a single-ended. This thing probably came out of some Motorola or RCA type late 60s, early 70s type hi-fi amp. Generally the red goes to the power supply and the blue goes to the plate. And on the other side you got a black and a green. This is probably a 4 ohm tap. A lot of the old speakers will have stamped on there like 3.4 ohms or something goofy like that. So this one's got wires to go to the speaker, and it's also got the little spade lugs to go to the speaker. That's a single-ended transformer, 1 tube. Probably a tube like 6AQ5, maybe a 6V6, I don't know. Okay, here's another one. Next step up. This one has got the black and the green, just like the other one. Probably goes to a 4 ohm speaker. You can see I've used this one before because I had some pigtails to it. But on this side, the primary, it's got a blue wire that goes to one 6V6. It's got a brown wire that goes to the other one. This goes to the power supply. This is for push-pull. This is for 2 tubes. The physical size of this thing tells you it's about 15 watts. I would say that the physical size of this tells you it's about 5. Okay, here's a little bit of a strange one. This one actually, we don't even have to guess at. We look at it and it says G, CT, and G. And we look at this side, it says P, CT, and P. And then it actually even says ratio 1:1. Wow, well, this is about all we need to know. What this is a push-pull plate to push-pull grids. This is an interstage transformer. Pretty rare. You're not going to be using many of these. Okay, so this is the transformer stuff, and what I'm going to do here is show you how to take a transformer, because this is about building amplifiers. This is not about theory. I know you guys like to build amplifiers, and there's a lot of good stuff on the internet about the theory and the hoopla and all that kind of stuff, but let's get down to what are we going to do? What is this thing, and what can we do with it? Because you just got this thing at a garage sale, and somehow you believe it's an output transformer. It may not be, because how can you tell the difference between this guy as an output transformer and this guy? You really can't. Well, you can if you have some experience. You can look at the windings if they haven't been changed, and you'll pretty well conclude that this is a power transformer, and you better be damn careful. You don't want to fool with this thing around other people. You don't want to kill yourself. You don't want your pets walking across and kill your pets. This thing is deadly. But if you've got some reasonable inkling of an idea of what it is, I'm going to show you how you can determine what the primary to secondary turns ratio is, what the primary to secondary impedance ratio is. It's just a square of the turns ratio. That's all the math we're going to be doing. And then determine what type of tube you might want to match it to. You're obviously going to have to know whether it's push-pull or single-ended. And then, of course, these things come in every size. This is the one that I used in my 1.3 kilowatt amp. See, this one gives you an idea of where to start. I happen to know that it's an output transformer. And it actually says right there, I don't know if you can see it because the light says PRI, primary. This is the primary. These are secondary windings. So there's going to be a common one, and I don't remember if they're all in series or not. I don't remember if they're all one winding with taps off of it. But maybe we'll use this one too, and we'll put in some low voltage on the primary. Low voltage on the primary, not the secondary. Because if you have a transformer, say like this, that has, let's suppose the turns ratio is 40:1. And you put in 40 volts over here, then you get out 1 volt over here. Nothing goes wrong. But if it's 40:1 and you put in 40 volts over here, on the secondary side, you get out 1600 over here, because it's going to multiply your voltage times 40. It's either going to divide your voltage if you put it here on the high impedance winding. If you put 40 volts on the high impedance winding and the turns ratio is 40:1, you get a volt. If you put 40 volts the other way around, you get 1600. You don't want to go that way. It can kill you. It'll explode your meter. Things will go terribly wrong. So you've got to make some very simple, primitive type of measurements. And after you do that, then you can very carefully start determining what the transformer is. But you got to do it in a safe manner. So this is the first part. I think it's very important that I say all this, because I don't want somebody to just, well, we'll just take a AC power cord and we'll hook it up here and measure what comes out the other side. Well, you're going to blow the fuse, you're going to blow your transformer, and God help anybody that touches this, because then they're going to be injured if not killed. So there you go. That's the first part. Now let me move things around, and I'll start trying to make some measurements that are meaningful. Okay, here's the part that I want to show you. I've got this analog meter on R times 10. I got it on the ohm scale. See there. And I'm going to look at this output transformer, and I'm going to look at the primary. This is the high impedance winding. Now watch the meter here as I hook it up. See, watch it rise as the magnetic field builds in the transformer. Okay, that measures about 15, which is times 10, 150 ohms. Makes sense, because I have experience with this, and I'm trying to give you some experience. This measures about half. Indeed it does. Okay, now let's turn it around and look at the secondary. This would be where the speaker goes, the 4, 8, and 16 ohm output stuff. And look what we see here. Looks like it's dead shorted. Well, it's not. And we're going to use another meter to actually measure. What we're going to actually measure to determine what this transformer is the voltage. And we'll get to that in the next step. But see, it looks like it's shorted. The reason it looks like it's shorted, which it isn't, is because the secondary winding is made out of that big wire. It's made out of wire the size of this stuff right here. It's made out of this size wire. Whereas the primary over here is made out of a lot of turns of very, very small wire. So you cannot put your meter on there and measure 4, 8, and 16. It doesn't work that way. Okay, now watch this. This is that big power transformer again. This is that 2000 volt power transformer. Now watch what happens when I measure the primary, which is the 120 volt side of this one. Look at this. It looks like it's shorted again. Well, it's not. It's not shorted. It's a perfectly good transformer, but it measures so low because this is a probably 2000 volts, probably 300 milliamps. That's 600 watts. This is a big transformer, so it's got larger wire and less turns over here. So it looks like it's shorted again. Okay, and then we go back to the secondary side of the high voltage winding, and look what we get. See, so these numbers, you're not going to be able to read the numbers off of your meter, whether it's analog or digital. Analog meters for this is actually a good idea. You're not going to be able to read the numbers off of here and get any numerical meaning out of them. You're going to get a relative meaning out of them. Okay? I'm only throwing this in to let you know that when you start measuring transformers and you've measured one or two, you don't have much experience at it yet. You've got to measure a lot of transformers over a lot of years, and then you understand. Big wire, low impedance, big wire, low DC resistance, lots and lots of turns, or higher DC resistance. Same thing over here. This is the low side. This would be, comparatively speaking, this would be like the speaker winding if you were comparing it to a output transformer, and this would be like the parts that go to the push-pull plates. And I'm going to actually go there with you later, and I'll show you that you actually can use some power transformers as output transformers. Think about it. What if you hooked this across push-pull plates? What would you get out here? Not the right thing, but what would you get out here on this 5 volt winding? I've got them twisted together wrong. What would you get out here? What would that impedance ratio be? Something to think about, huh? Okay, now we're actually set up. We're going to measure this transformer, the one that I just talked about. This the 6V6 push-pull transformer. We're going to get the turns ratio. And what I have set up is a variac right here. I've replaced a fuse here with a 1/2 amp. It's normally a 5 amp, just for safety. When I plug this in, what that is this little 6 volt transformer right there. So they've got 6 volts output, and I'm going to put the 6 volts into the primary winding, the high impedance winding of this little transformer, and we're going to measure the voltage going in here. You'll be able to see both of these at the same time. The voltage coming out here. This is the voltage that would be going in on the primary winding that would hook from plate to plate, and this is the speaker winding right here. So let's get started here. I've got my variac. You can't see it here, but I'm going to be operating this. I'm going to be turning the voltage up and down with that. Okay, so I'm going to take the leads right here. This is the output of this little 6 volt transformer, and I'm going to put it across here. All the way across, not to the center tap, but all the way across. Whoops, I got it on center tap right there. Right here instead. Okay. Now I'm going to start running the voltage up. This voltage right here is going to be what's coming out of the 6 volt transformer. See, there we go. 2 volts. Look what's coming out the other side. I want you to be able to see this clearly. Yeah, I believe you can see that. Let's run it up to some number. We're relatively safe here. Let's run it all the way up to there. I've got it turned up all the way. This is good. Now we're going to write this down. I'm going to write it down here on a piece of paper, and we'll show that in a minute. So I'm going to put down the primary voltage as 9 volts, and the secondary voltage is 0.2. 0.2. See, right there like that. We're going to record the primary voltage, the secondary voltage, then we're going to do the turns ratio. We square that and we get the impedance ratio. So let's just stop right there. Turn everything off. Go over to here. Go over to our so if we divide 9 by 0.2, 9 enter 0.2 divide, we get 45. So we get an exact turns ratio of 45 to 1. 45 to 1, which is an impedance ratio of that squared. So if we square that number, we get an impedance ratio of 2025. 2025. Okay, now in its simplest form, what we're going to do is this is going to be our primary. One with lots of turns. This is our speaker terminal over here. If we put 8 ohms out here, what we're going to see over here reflected, what this side of the transformer is going to be is 8 times that. Enter 8 times. So it's going to be 16,200 ohms. 16,200 ohms. Now if this were 4 ohms, it would only be 4 times 2025. 2025, enter 4 times. It would be, whoops, 2025, enter 4 times. It would be 8,100 ohms. Now that's more reasonable. We would have 8,100 ohms if this were 4 ohms. So you can see, I hope, where we're going with this. Same transformer, but by changing the load here, by changing the speaker load, we're changing the primary load. We're changing the impedance of the primary of this transformer. So this is a pretty reasonable expectation for a single-ended tube. Let me get the tube manual and we'll see what kind of a tube would want like 8,000 ohms, somewhere in that range. Okay, now using the good old RCA receiving tube manual, you can see this poor book has had a lot of use over the years. If we look up, right here, so we're looking up at 6V6, over here on this page, push-pull Class A amplifier, right there, look what it wants, 8,000 ohms. See, right there, whoops, lose my pages. At 285 volts, it wants 8,000 ohms plate to plate. See, plate to plate resistance. Effective load resistance, 8,000 ohms at 285 volts. At 250 volts, it wants 10,000. So there we go. We've got the perfect match for a 6V6 amplifier right there, which I did not know absolutely for sure that that's what this little transformer came from. But there it is, right there. To a 4 ohm load. It wants a 4 ohm load. This little transformer across 2 6V6s with about 300 volts on the plate. 4 ohms out here. It's perfect. That's the way that you can determine in its simplest form what a transformer is. And that can get a lot more complex than that, but that in a nutshell is what it's all about. Okay, let me set up some other stuff here. Okay, let's do this once again. I was going to do it for that big multi-tap transformer, but if you can do it for one, you can do it for all. Here's that little transformer. I don't want to move it much or it'll disconnect. This is that little single-ended output transformer. I've got the voltage going in on the primary again, and we're measuring the output right here on the secondary. If you can see my hand down here. Primary voltage, secondary voltage. Let's turn it back up. Okay, there we got our 9 volts again on the primary. 9 volts on the primary. 0.374, 0.374 on the secondary. And that gives us 9.374 divide. That gives us a turns ratio of 24, or an impedance ratio, if you square that number, of 579. So if we put a 4 ohm load on it, we're going to get reflected back to the primary. If we put a 4 ohm load on the secondary, the primary is going to want to see 4 times that. 4 times, so it's going to want to see a 2,300 ohm load. So we're going to have 2,300 ohm primary and 4 ohms. Or if it's 8 ohms, 579, we'll take 579, 8 times, we'll get 4,600 ohms. 4,600 ohms for 8. Now, let's look in the book and see what kind of tube that might match. Let me find it. Okay, once again, looking in the RCA tube manual, we see right here, here's a 6AQ5, just something like we suspected it to be. A little beam power tube, a little 7-pin. If we look right here, we'll see that the plate resistance is approximately 1,970 ohms. Right there. 1,970 ohms. And we got a match of 2,300. That's pretty darn close. That will work. Let's try a 6BQ5. Okay, 6BQ5 right here, which is an EL84, which we're all musicians are familiar with. Right here, its plate resistance for a Class A single-ended amplifier is, what does it say, plate resistance? It wants 38,000 ohms. Not going to work very well for a 6BQ5, but it'll work pretty darn good for a 6AQ5. So that's how you do it. In a nutshell, that's quick and dirty, but if you take this and you understand this quite well, then you can figure it out. You can make your own amplifiers. You can get transformers and decide what tubes to use. You need a tube manual. Got to have that. You can get them online. You can get them on CD. You can get everything that's practically ever been published for 10 bucks or less, pre-shipping. So I hope this helps. Be safe. Be very, very careful with transformers. They can kill you. But and you just got to have some experience in knowing the difference between audio transformers, filament transformers, power transformers. You just got to look at them and think about it. If there's numbers on them, look them up on the internet. Do all the research you can before you start measuring, and you may not even have to do the measurements. But if you do have to, because like this guy right here, whoops, let me turn it off. See there? Got to be careful. Not going to kill me, but I still don't want it. I don't want any sparks. But you're going to find a lot of this kind of stuff salvaged, and you're going to be able to remove this kind of stuff from things that you buy from garage sales, estate sales, all that kind of stuff, ham radio operators, wherever you might get it. So there you go. Hope it helps.